the same answer that way. Find the angle between two vectors. So now we have two ways to calculate the dot product with two vectors. So we have this and we have this. So solving the last equation for cosine of theta gives us a way to find the angle between two vectors. So when you go ahead and solve this for theta, you would divide both sides by the magnitude of u times the magnitude of v. And you're left with cosine of theta equals the dot product of vector u times vector v divided by the magnitude of u and v multiplied together. So this is going to come in super handy when you're trying to find the angle between two vectors. So again, to rewrite that again, so it's vector u, the dot product between vector u and vector v divided by the magnitude of v times the magnitude of u. Okay, so let's use that to actually solve some of these things. So draw the angle between u equals 2i plus 3j. So if I were to do u, so it's 2 horizontal, 3 vertical, so there's u. And then if I had to draw v, we would have, so v is over 4 horizontally and down 1. Okay, so that angle in between them is going to be right there. So if we wanted to use that angle between vectors theorem, we can. So that formula is the cosine of theta equals the dot product of u times v divided by the magnitude of u times the magnitude of v. Okay, so we need to figure out each of those components. So we know that, let's see, so u times v, let's do the dot product first. I shouldn't say u times v, the dot product of u and v. So the dot product of u and v is going to be 2 times 4, so multiplying the horizontal components, plus 3 times negative 1, multiplying the vertical components. So that gives me 8 minus 3, which is 5. Now to figure out the magnitude, so the magnitude of u comes from taking the square root of the horizontal component squared plus the vertical component squared. So I end up getting the square root of 13. And then the magnitude of v, square root of 4 squared plus negative 1 squared, which gives me the square root of 17. So now we have, I'm going to finish this up here, the cosine of theta equals 5 over the square root of 13 times the square root of 17. So if we want to get this theta isolated, we'll take the cosine inverse of both sides. And we end up getting about 70.3 degrees, which makes sense because if this whole thing is 90, we know this is about a little less than 90, and then adding that, so it looks right in the picture, in my opinion, justified. So that is a really great formula that you can use if you're ever trying to find the angle in between the vectors, and that's going to come in really handy when we're trying to solve these types of things, because then we can use the law of cosines or the law of sines. All right, understand the significance of the dot product and parallel vectors. What does the dot product tell us about vectors? The angle between the vectors gives us a measure of how well the vectors are aligned. So if two vectors point in the same direction, then your angle is going to be 0. If they point in opposite directions, then your angle is going to be pi. In either case, the vectors are parallel. So if you end up getting two vectors are parallel if there's a non-zero scalar, so that when you take one times the other, you'll get it. So determine if the vectors 4i minus 8j and negative 2i plus 4j are parallel. So first let's draw a sketch so that we can see. So if I wrote v, so v is going to be going over 4 and then down 8. So there's v. And then W is going to be going over 2 and up 4. There's W. So you can see that these are going to be parallel. They're going in that same alignment. So let's just actually check it using that angle between two vectors theorem. So we know that the cosine of theta equals the dot product. So when I do the dot product, I'm going to get 4 times -2 plus -8 times 4 over their magnitudes. So the magnitude of V is going to be the square root of 4 squared plus 8 squared. The magnitude of W is going to be -2 squared plus 4 squared. When I do that, take the cosine inverse, you end up getting that theta is pi. So when your alpha is pi, you end up seeing that these are parallel. Now, if we had to rewrite V in terms of W, do you guys see if I took V or W and multiplied it by a scalar of 2? So if I took W, so 2 times W is going to be -4, 8. So I'm close. But if I made it the -2, now that would be +4, -8, which is what this is. So we can see that there's a vector, there's a scalar that we can use. I can multiply W by -2 and I get vector V. That's another way that you can tell that these are parallel. So we can use this also for orthogonal. So orthogonal basically is another word for perpendicular. So two vectors, V and W, are orthogonal if and only if their dot product equals 0. So to understand this, so determine the vectors, if the vectors, these two vectors are orthogonal. So let's first sketch them. So this would be 1i minus 1j, so over 1, down 1. So there's your vector V. And then this is vector W is going to be over 1, up 1. So that looks like a 90-degree angle, or pi over 2, but let's actually check it. So using that dot product, I'm going to get 1 times 1, 1 times 1, plus -1 times 1, which ends up giving us 0. So that checks out. Determine if the vectors 2i minus 3j and -6i minus 4j are orthogonal. Draw a sketch of the two vectors to see their angles, and then find V times W, or the dot product of V and W. So if I first were to draw these, I'm going to draw them in green. So V is over 2, down 3. So there's V. W is 6 in the negative direction, so 1, 2, 3, 4, 5, 6, and then down 4. So they look like they're going to be orthogonal, but let's check. So the dot product of these two is going to be multiplying their horizontal components, plus when you multiply their vertical components. So that ends up giving me -12 plus 12, which is 0.